Okay, Logan. Waves. Simple wave equation. Okay? Velocity of a wave equals the wavelength times the frequency. Velocity is in meters, frequency is in 1/seconds. Your units, those are your units. Okay, write that down. Velocity of a wave is your wavelength times the frequency, meters per second. I think it might have been Schrodinger. Remember the cat? I think it was it was both Schrodinger and Max Planck that came up with this. All right, I'm going to do one problem with you guys. We should be able to figure out the rest. Number 15. A sound wave is produced by a clock chime heard 515 meters away 1.5 seconds later. A, based on those measurements, what's the speed of sound in air? Velocity equals distance divided by time. It does not change for waves. So velocity equals 515 meters divided by 1.50 seconds. Okay? So all you got to do is divide. Thank you. 343.3333 meters per second. Okay? Now, you should also know, okay, just for information's sake, that the speed of sound can change based on the temperature. Yeah. Okay, it can change based on the day. It also changes versus the altitude. Have you ever put your ear on the side of a wall or on a desk and knocked on it? You notice how it sounds very loud? Okay, if you want to, you can try that right now. You can put your ear on the desk and knock on it. It sounds very loud. Yeah, and the reason is because the molecules are very close together, and so if one vibrates, they all vibrate. As you go up in air, up in altitude, there becomes fewer molecules, and one can't necessarily vibrate the other, so it doesn't sound as loud. And if you get into space, then it's very, very quiet because there's fewer molecules. So more molecules you have, the faster it'll move and the louder it'll be, because one molecule will vibrate all the other ones faster. Fewer molecules you have, or the more spaced out they are, the less they vibrate each other. So in hot air, sound is slower than in cold air. Okay? Number B, the sound wave has a frequency of 436 hertz. What's the period of the wave? Okay, well, 436 hertz is a measure of frequency, right? Well, what is the definition of frequency? Frequency is 1 over the time, 1 over the period, 1 over the time. Right, Indigo? So if 436 hertz is equal to 1 over the time, right, then isn't the time equal to 1 over 436 hertz? Yep, it's just opposites. So you're going to get a very, very, very small number. What'd you get there, Christian Leitner? Decimal, right? 0.0023. Okay. And number C. What is the wavelength? Well, the velocity of the wave equals the wavelength times the frequency. Okay, so if your velocity is 343.333333 meters per second, and your frequency is 436 hertz, which is 1 over seconds, the seconds will end up canceling and you'll be left with meters. Okay? See that, Chris Parham? The seconds will cancel. That makes sense? Riley, that doesn't make sense. You don't like that, Riley? You can't see it? Forgot your glasses. 0.79? Yeah. So 0.79 meters. Yeah. It's really not. It's just a 3-variable equation, guys. Okay. Velocity is wavelength times frequency. 1 over seconds is a frequency. It's also a what? A hertz. Hz, hertz, like the radio. Frequency is 1 over time. Time's measured in seconds. Okay. See that, Greenie? Time. Time is 1 over frequency, is it not? Same thing? Okay, so very simple. That's longitudinal waves and transverse waves. Period. Do DHS physics, like, comment, subscribe, smash the bell. Period.